welcome back. Right, question 5 is a quadratic equation with roots. So this is like the sum and product of polynomial roots. Right, we start off by writing down our coefficients. So a equals 1, b equals -4, c equals 10 for this equation. And we know that the sum of our roots, so alpha plus beta, is equal to minus b over a. One of those things you've just got to learn. So alpha plus beta is equal to minus -4, so negative -4, which is 4, over 1, which is just 4. And alpha beta is equal to c over a, so that's just equal to 10 over 1, which is just equal to 10. Lovely jubbly. Okay, so show that 1 over alpha plus 1 over beta equals 2/5. Right, so up at the start there we had that alpha plus beta is equal to 4 and alpha beta is equal to 10. I'm just going to write that down again because we're going to use it now. So 1 over alpha plus 1 over beta. We're going to have to use a little bit of magic here, a little bit of algebra. So we're going to cross multiply this. So 1 times beta plus 1 times alpha. And on the bottom you're going to have alpha beta. So just your cross smile that you've been doing with your fractions for ages. Just get everything over the common denominator there. So alpha plus beta is 4, alpha beta is 10, so that is just 2 over 5. So the sum of these new roots for this equation, oh no, hang on, sorry. Right, so we've got 1 over alpha plus 1 over beta. Right, now we want to find a quadratic equation with integer coefficients. That's important. So we need to make sure our answers are integers. We can't have fractions in there, which has roots alpha plus 2 over beta and beta plus 2 over alpha. So I'm going to start off by adding our roots together. So alpha plus 2 over beta plus 2 over alpha. Okay, combine the bits that we know. So we know alpha plus beta. And if we write that now as 2 over alpha plus 2 over beta. So we've not done anything apart from change the order. That will give us alpha plus beta plus, and we're going to cross multiply this again. So 2 beta plus 2 alpha all over alpha beta. Okay, so that gives us alpha plus beta, which we know is 4 from the start. Alpha plus beta is 4. And then we've got 2 lots of alpha plus beta on the top, so that gives us 8. If we took a common factor of 2 out here. And alpha beta on the bottom, that's just equal to 10. So that gives us 4.8. But we're not messing about with decimals here. We need to get this in terms of fractions. So 4.8 is the same as 20. I want to say 24 over 5, but I'm just going to double check. 4.8, yeah, 24 over 5. Okay, so the sum of these roots now is 24 over 5. Right, so now we need to do the product of these roots. So we want to do alpha plus 2 over beta times beta plus 2 over alpha, and be really careful when we expand this out. So this was our sum here, and here we have our product. Okay, so we've got alpha beta plus 2 beta over beta plus 2 alpha over alpha plus 2 over beta times 2 over alpha gives us 4 over alpha beta. We can cancel things out. That beta and that beta cancel out. That alpha and that cancel out. And can't speak. So you're left with alpha beta plus 4 over alpha beta, which we know alpha beta is 10. So we've got 10 plus 4 over 10, which gives us 14.4, which is the same as 72 over 5. Okay, so our new quadratic equation that we're looking for, because we're looking for a new quadratic, we know that the sum, let me just change colour, we know that the sum, of our roots, is equal to minus b over a. So that's equal to minus b over a. And the product of our roots is equal to c over a for our new equation. So if we make a equal to 5, then that means that b must be equal to minus 24 and c must be equal to 72. Okay, Just be careful with this negative here, this minus b over a. Minus b is 24. So that gives us the quadratic equation 5x squared minus 24x plus 72, and that is equal to 0. You lose a mark if you don't put the equal to 0, because without an equal sign it's not an equation. It's just not.